Hey everyone, welcome back to another video. If you've watched much of my content, you'll hear me talk a lot about building frameworks to common GAMSAT problems. So what I mean by that is really trying to look past the individual question and more thinking about what are the skills that I'm actually needing to do to solve this problem, and then hopefully grouping questions together based on if they have similar problem solving approaches required or not. And whilst I think me talking about building these frameworks and how you can go about that is very helpful, it's probably more helpful to actually see it in action. So today I'm going to show you my top framework, which is in organic chemistry, and hopefully that'll inspire you to start building your own frameworks. As I mentioned, this organic chemistry/reactions framework is my top framework. And the reason for that is not only does it have a large number of questions in the practice material that actually use this skill, the questions involved in this framework are very similar question to question. So what we're going to go through today is some of those ACER practice problems, and I'll show you that really a lot of the questions are just the same thing, rephrased in a different way. And really the value from these frameworks is when you actually see different questions and how similar the problem solving approaches are. So I really recommend watching all of the questions together and compare and contrast them, because that's when you actually start to build those together into some kind of mental map. And if you find this video useful, which I guarantee you will, please like the video, comment and subscribe to the channel. Okay, so I have done an organic chemistry video before and it did touch on some of these concepts. But really what you need to be able to take away from that video is being able to name organic compounds like this really well. So if you look at these and you can't really identify the functional groups, or you wouldn't be comfortable naming molecules like this, please go and watch that video first and then come back once you have the basics. So assuming you feel comfortable naming molecules, let's proceed. So how I classify this organic reaction/organic chemistry framework is really when you have some kind of reaction detailed like this. So it could be a worded problem or it could be a diagram like this, but you'll see that one thing goes into another. And really what we have is we kind of have these fixed regions, which I've highlighted in yellow here, and then we have these variable regions, which are our R groups. Now the way, which I've done in blue. So how I like to think about this is that it's like you're making something. So these are the ingredients. So if you put certain ingredients in, you will get something out. And they're basically what our yellow groups are. But you can have little things attached to those ingredients, and that will change what you get out slightly, but it will still resemble that thing. So if we look at our product here, this is some form of alcohol, but it could be, those R groups could be 5 carbons long, could be 1 carbon long, could be 0 carbons long. And really it's still going to be an alcohol, but it's just going to have a different size. And we had to obviously put in an ester in here. So really that's how I like to just conceptualize it in my head, is you put something in and you get something out, but what you put in and what you put out might be different sizes, or there might be some little variations, and that's what those R groups are. So I've just kind of written that down here. You will get a reaction. Now it could be worded or a diagram, and what you really need to do is I've kind of grouped it into two things just to simplify it. So you're either going to need to determine what the R groups are, or you're going to need to generalize the reaction. So we're going to go through each of these one by one, and I'm going to be using some practice problems from the ACER material just to demonstrate how similar these are across multiple questions. But before we jump into the hard stuff, let's just go with a nice easy example. So here I've kind of drawn a really messy molecule down the bottom, but that's obviously still in the form of this thing above. And what I mean by when we're determining R groups is we really need to see, okay, which ones of these groups are the fixed regions and then which ones are the variable regions. So really what I want you to be thinking about when you're determining R groups is almost like you're comparing what you've got to a template. So if we compare this to a template, I'd be finding these kind of fixed regions. So you can see that that's exactly the same as what I've got in my molecule above. And that tells me that this thing on the right, this is R dash, R dash, and this one on the left, this is just our single R. Okay, so you can see that they are just what those groups are based on mapping that molecule to the template. So once you've mapped it to the template, you can just figure out what those R groups are. Now, once you've got them, you might then need to put them back onto this molecule. So now we have a fixed region of just this COH, so you can see that that's exactly the same as that molecule. And all we need to do is just plug our molecules in. So whatever our R group are and our R dash, we just put them in here. So we just put our CH3, CH2, and then a CH3 over here. And those are just, I've basically just taken these and just plonked them onto that molecule. And then, yeah, you might need to name that molecule, or you might need to pick that out of a drawing. So a lot of the time you're going to be going between a worded equation and a diagram and drawing things out. But really your goal should just be, you need to map your molecule to the template to figure out what the R groups are. And it's not until you're saying what the R groups are that you actually realize that that's a bit of a tongue twister. Okay, so that first part was kind of determining what the R groups are. And then this second part is more generalizing the reaction. So this one, it can take a few different shapes. So one of them I kind of think of is asking you what would be possible or what would not be possible. And then also just kind of classifying what the limitations of the reaction are, if that makes sense. So the first example really is that, so let's say that the reaction says somewhere that it needs to be an ester and it needs to go to an alcohol. That means that this first R group can't be a hydrogen, because if that was a hydrogen, then this would actually be a carboxylic acid group. So that's not possible. So that might be something that they ask you to generalize, is what groups are possible here and which ones aren't. And by the same token, it might say something like with the alcohol, it might say which will produce a primary alcohol, for example. So if it's asking for a primary alcohol, that means that only one of these groups can be carbon-based and the other has to be hydrogen. So based on that, we know that R can't be hydrogen. So we know that this R has to be carbon-based and this R dash has to be hydrogen. So that kind of allows you can then map that back maybe over here, and that will help you figure out what those kind of inputs need to be. So just a quick recap before we dive into the GAMSAT problems. You will get a reaction. It'll be either worded or as a diagram. And what you'll need to do is to determine the R groups, which could help you go from the reactants to the products, or from the products to the reactants. And you'll also need to generalize that reaction. And what that really means is determining what parts are possible and what parts are not possible, or what groups are possible and which ones aren't. So I'll put all of these questions in the description if you want to go through and try them for yourself. But really what I'm going to be doing here is just going through and showing you how these questions relate to those two things I was talking about, determining R groups and generalizing the reaction. Okay, so this first question that we're going to do is practice test 1, question 57-59, which is in the green booklet, if you call them that way. And basically, this is the reaction that we have. So I would just kind of notice, obviously you don't have the luxury of highlighting in the exam, but you can kind of still mentally just take note of these regions. So I would just say that these are the fixed regions, these are the ingredients that must go in. And then the things that change is that there's this R group on the aldehyde, which goes over to that left part of the molecule. And there's this R dash on the alcohol, which goes to the right. And you can see that that's going to be important. So based on what the alcohol has, that R dash is going to go next to this oxygen. So you can see that the order is going to be important, and that's why it's so vital that you can actually name these compounds effectively. So the first question reads, which of the following structures represents the hemiacetal that exists in an equilibrium solution of propanol and ethanol? So if you just think about that question, it's clearly asking for the product. So it's given us two reactants and then it's asking for the product. So that's the kind of pattern that I want you to be picking up on. Now they've actually given you the full chemical formula for this equation. I think that's rare. I think usually you're going to need to do some kind of mapping between the word and the drawing itself. So I think that's why I really emphasize being able to name molecules effectively. But in this case, you also have the chemical formula. Regardless, we're just going to act as if we didn't have that. So it's propanol. So Mary eats plums. So that's a 3-carbon molecule. And a lot of the time, you're just caring about the carbon. So you don't need to write it, completely accurately. You can see that I've left a lot of hydrogens off, but that's fine for this. And we also had ethanol. So Mary eats. So that's 2 carbons, and then an OH. So if I just kind of go and color code these in, and again, you don't have this luxury, but it shouldn't be too hard. You could even just cross off the fixed regions if you want to. But you can see quite clearly that mapping those molecules to the templates, it's very clear to see what the R groups are. And then I just need to transpose them onto my original molecule. So I draw my, sorry, that's an O, and then CC. So I draw, that's that. That's my fixed region, and then that's my R group there. And then if you look at the options, it's not exactly like this. So that's the kind of thing that you should be expecting. Once you have the molecule, there's going to be an additional step. So you might need to name this molecule. That could be one of the answer options, or they might draw this out in a slightly different way. So how they've written that in the chemical formula is they've done this yellow region as CHO, OH up there. So it represents exactly the same thing, but you just need to be comfortable with things being represented in a slightly different way. But once you find that that's how they've written out that middle fixed region, then you just need to find the one which has 2 C's either side of that. So this next question is asked, which reactants could have formed this hemiacetal? So you can see even the way that I'm asking the questions, it's very clear what you should be looking for. You should be going from products to reactants, or reactants to products. So they've drawn it out like this. Now we would have figured out from the last question that this relates to that fixed region that I've drawn above. And then it's literally just finding what the groups are. So this one has to be the R, because as I mentioned, the O, the thing that's next to the O is the R dash. So once we've figured out those R groups, so again, we're just determining what the R groups are, we then just write them over here. So in this case, we'll have 3 carbons, which is our R, before we get into the aldehyde group. So this will be butanol. And then the alcohol we'll have is just a 2-carbon alcohol. So that's just ethanol again. And apologies, this last one's got a little bit messy, but it's basically just asked for which one of these 3 structures are displaying the hemiacetal structure. So the hemiacetal is the molecule on the right. So we're just looking for that. So I would just be looking for that particular functional group. And it's quite clear from, obviously you need an oxygen, so it's a good place to start, just looking for landmarks. I find that's a very common theme that you'll see in this framework, is looking for landmarks. So for example, we've got that oxygen. We can see that that's bonded to a carbon, which is bonded to a hydrogen, which looks good. And then we've got this OH there. So often these structural questions will kind of give you a bit of a question mark over if this is okay, but then you can go back to the stem and you'll actually see that there's a bit there about ring structures being okay. So if you ever I find that when you're doing these determining or generalizing the reaction questions, you can kind of get a little bit tripped up and be like, is that okay or is that not okay? If you have that question mark in your head, there'll usually be some information kind of explaining why it is or isn't. So this one is all good. This one, structure 3, is okay. If we go with structure 1, we can see that we've got an oxygen over here, but the OH isn't attached to that carbon. So this one we can just say is no good. And then with structure 2, we can see that we've got this carbon here, which has an O, and it has an OH attached as well, and it has a hydrogen. Now, my only question would be, again, kind of asking questions of yourself. So if that is the structure, that means that this part going this way in this molecule to the left will be the green, the R dash group. Because remember, the carbon group attached to the oxygen is the R dash. So that's the one that comes up here. And if we go by that logic, that means the other group attached to the carbon must be the R group. So in that case, the R group's actually one of these hydrogens here. So this is a really good example of questions which make you think, is that okay or is that not okay? So if that group is a hydrogen, I hope that bit's made sense. If that group's a hydrogen, it means this group over here is a hydrogen. Now in this case it's okay because that would actually be methanol. That's just the most basic aldehyde, which is a 1-carbon aldehyde. However, if the roles were reversed and this one was the hydrogen, it actually wouldn't be possible anymore because it says that we need to put in an alcohol, and if that was a hydrogen, that would actually just be water. So it's not an alcohol anymore, and therefore that would not be possible. Okay, so the next question I wanted to do was sample questions 17 to 21. And this is a really good example of very much the same skills in action. So I've gone through it and I've just kind of color-coded the fixed regions again in yellow, and then all of the different functional groups, which are the variable things, all the R groups that we have. Now the first question that we have, question 17, is basically just saying, if we had butanoic acid, what would the R groups be? So butanoic acid, Mary eats plums before, and I find when you're drawing these out, just try to match the format that they give you. So as I've shown you before, they can write molecules in different ways, and I find if you can just do it in their format, it actually helps you kind of map things, because again, you're just trying to map things to a template. So this would be the yellow region, that's red, that's blue, and that's green. Now the trick here is that I think they know that most people are going to draw them out in a straight line, and that actually changes what the kind of R groups are. So it's been a little bit tricky, but essentially you just need to realize that these two are interchangeable, because if I drew this C down here and this H up here, it would still be the same name. It'd still be butanoic acid. So they've been a little bit tricky, and that's what I mean with they're trying to give you an extra step. So once you've drawn it out or you've named it or whatever, there might be some extra step there. So just think outside the box, but you can rule out all the other ones. And once you don't see your option there, just know that your answer's right and just think about other ways that they might be representing that molecule. So the next question is exactly the same, and this one's saying, what would the R groups be if it was propanoic acid? So Mary eats plums before, so we draw out our 3-carbon molecule. And again, we just go through the same process, and we actually realize here that all of the groups are actually hydrogen. So we immediately pick A. No, we don't. We need to just think that there could be something else here. So if there's something like that, it feels a little bit easy, especially off the back of the last question. So if you look at the options, B actually still fits the bill, because all we have said is that R dash, R double dash, and R triple dash have to be hydrogen, but we haven't said anything about this R group over here. And if we actually look into that, we remember that this group that goes in has to be carbon-based, because if that was hydrogen, it wouldn't be an ester, it would be a carboxylic acid. And the reaction clearly states that it needs to be an ester, and there's a few sentences in the stem as well that demonstrate that. So this is an example of kind of having that awareness that there could be something else, and it's kind of testing both what the R groups are as well as what's possible in one question. So the answer to this one's actually B, because all we figured out by drawing the molecule out is what these groups need to be. But remember, there's another R group which we haven't determined yet, and there will be information to tell you which one is correct. Okay, so next question, it has a bunch of molecules with this 4-hydroxy in it. And if we look at our structure, this has to be a 3-hydroxy. So there's only one molecule with a 3-hydroxy in it, and that's why that's the only one that's possible. So this is what I'd kind of put into my generalizing the reaction, what's possible and what's not. And you just need to spot that pattern that the hydroxy needs to be on the third group. And hopefully when you draw one of those 4 hydroxy groups out, you'll see that the fixed region can't be what it needs to be. You will have something where you've got 4 carbons and then your hydroxy, and that's clearly not the same as the one down there. You need that hydroxy on the third. So that's about how the ingredients that you put in need to be those ingredients. They can have some variability with what's attached to them, but the core ingredient needs to be exactly what it says it is. So question 20 has given you a very scary looking 3-hydroxy 4-ethyl hexanoic acid, and it said, which are the 2 reactants? So it's quite clear that it's asking for reactants to products, and that's kind of what I put into my determining R groups category. So again, I've just drawn this out, and we can just go through and highlight the fixed regions. That then gives us these variable R group regions. And you can just name those, and then that's going to be your reactant. Once you've put those back, so you can just substitute all of these R groups into these respective reactants, and then name them, and that will be your answer. And this last one's a little bit tricky because they've given you these unorthodox kind of names like acetone and acetate, but you just need to know that they're the most basic forms of ketones or esters. So it is handy just to know what those are, as well as like acetic acid. But if you do know them, you'll be able to draw these out, and then it's exactly the same process. So I've color-coded all of these again, but basically you can then just translate these red and blue ones over here. This hydrogen can just go on there, and this purple propyl bit actually doesn't matter, and that ends up getting attached to the OH because, so it doesn't matter because they've asked for what the final molecule is. So once you can put those groups on there, once you've figured out what propyl bromoacetate is, you can put those groups on and then name it, which is answer D. So this video is getting a little bit longer than I thought it was going to be, so I might stop it there. But if it's useful, please let me know, and I can continue with the other questions that I have in my kind of organic reactions framework. But I hope that these 2 examples showed you that there is a lot of similarity between the questions. You're really going to be given a molecule or given the name of a molecule and a reaction, and you need to figure out what the R groups are, and also just be able to generalize that reaction in terms of what's possible as well. So I hope this video was useful. If it was, please like, comment, and subscribe, as I said before. And if you do want to see me make a part 2 with the other questions in this framework, please let me know, and I'll be more than happy to do that. But until then, good luck with your GAMSAT prep, and I'll see you in the next video.